When pin tuning, a term that people don't really understand too well is the I term, the integral, or what I say we should really be calling the imbalance term. The I term, the imbalance term, is responsible for adjusting any imbalance in the quad. If you have a center of gravity that is shifted from the center of mass, you will have an inherent imbalance in the quad. That also goes for rotational speed. Obviously, if your rotational rate, the center of rotation, the center of mass, which is the center of rotation, is different from the center of gravity, that would cause an imbalance in that rotation trying to stop or hold a steady rotational rate. But there's other factors that come into play with the I term. And what you find is that it's not really common knowledge to understand the relationship between the I term, the imbalance term, and the P term, the pushing term, and how those two impact each other and affect each other, and how really the P term is the damping term for the I term. So let's talk about that, and we show you some simulations so you can see this is not an opinion. This is a fact of how it works. So I'll drop a link down to this simulation. You can check it out. It's a free simulation that somebody hosted on their website. It's very easy to use. And as a result, you can check out what we're going to talk about here for yourself and play with it and just look at the different scenarios. And so when you do come into this simulation, a couple things I would change is the sampling rate here. I would take that down as far as you can go. So take that down to 50 milliseconds. The other thing I would adjust on here to get to the same result that you're seeing from what I'm inputting here is this user output value right here. I think the default was 30. Just change that to a 1 and then hit apply. And then that will give you the same results that you're seeing on my screen here. Now, as this shows on here, we have a couple lines that aren't moving, aren't doing anything right now. So the first line here, the blue line here, is the control set point. So that is equivalent to us moving the sticks. So if I grab the stick here and go from 0 deflection to full deflection, which would be, say a full rate rotation, we're going to use that as an example for this controller. That would be like me taking this set point and adjusting it. You can see now I'm taking that blue line, and I went from the set point of whatever it was like negative 150-ish, and it changed up to 37. And from there, you can see how the PID controller adjusts here. Here you also have the green line is the controller output, and then this controller input. So the controller output is what is going to move the controller input line. So the input line is the quad, essentially. Think of the red line as the quad itself. So again, the blue line is the sticks on my controller. The green line is the output from the PID controller, and the red line is going to be the quad, and we're going to be changing the rotational rate of the quad in this example. So again, if I take this set point and change it like that, that's going from 37 degrees per second and changing it now down to negative 28 degrees per second in basically an instantaneous move, like moving it over and just holding it there. And then you can see how the controller output and then how the red line, how the quad is adjusting. So really the first thing is, why do we need an imbalance term? And you can see that here in some of the example I was just showing. So as I mentioned in a previous video, a lot of times they'll refer to the proportional term, the pushing term as Kp, the imbalance term or the integral term as the Ki, and the derivative term is the Kd. That just has to do with the constants, and there's constants going into these equations. The constants are essentially the gains. So what I have going on here is I just have a P controller. So it's just a P gain. I have the I gain set to 0 and the D gain set to 0 as well. And you can see when I move my set point, what occurs, that the output, this green line, tells the controller to increase the gain, the pushing here, to bring this red line down to the blue line, but it never quite gets there. You can see the bigger shift. If I do a big shift with my output, pushing the output up, and you can see that this comes down, you can see, well, that red line never goes over top of the blue line. And that's why we need an imbalance. There's an imbalance here in this controller, and we need this I term to fix that. So now if I come over to my I gain and I just increase this just a little bit, so let's just go up to 0.1 on the I gain here. And this isn't scaled the same as Betaflight or iNav or anything like that. So just take these numbers for a grain of salt. They're just what this controller is using. And now I move this. You can see that the red line comes down. It's not really any better, right? This red line is not coming over top of this blue line yet. So let's increase the I gain to say around a 0.5. And you can see that I'm going to do that there, and then go ahead and change my stepped input here. And every time, again, I'm moving this bar, it's changing this. And you can see now with that my red line will go right on top of my blue line. And you could see how a 0.1 I gain was not enough. I needed something around a 0.5 to actually get this to come down on top of here. So you can see now every time I move this that we have enough I gain to correct for the imbalance in the quad and bring that red line onto the blue line here. No matter how I move this, that is surely going to keep coming right on top of it because it's correcting for that imbalance. So now you understand why we need that imbalance, that I gain term, that no matter how much proportional gain you have, your pushing gain, it's not going to correct for any imbalance. The I gain, the imbalance gain, is going to do a cumulative look back and say, okay, I'm close to the set point, but I'm not quite there. And it will close, it works to close that gap as long as you have enough I gain, where a P gain does not look at the cumulative error between where the set point is and where the quad is at. It just looks at the instantaneous gap between the two, and it will just never get you there. But let's look at this in the other direction. Let's take the P gain down to 0 and increase the I gain. And let me show you the relationship between the P and the I gain. So in this one, we're going to go ahead and grab that P gain, that pushing gain, set that down to 0. And we're going to take this I gain, we're going to put that up to about a 2. So just bring that up here. And let's see what happens now. So you can see they're right on top of each other. And let's go ahead and move my stepped input. Well, wow, we get quite a bit of output from the controller. And you can see that how we just get this oscillating behavior when we have imbalance term kind of doing all the pushing, because there is no proportional term. There is no damping term. There's no pushing term. There is no damping term. So this imbalance term, the integral here, is doing all, and it does. It eventually kind of gets the red line onto the blue line, but you can see we still have a slight oscillation that's occurring here. You can kind of see it more in the green line because that's the output, but you can see that there's more of an oscillation there. So obviously, how do we damp that out? Well, a lot of people will think that, and rightly so, the name of the term, the damping term, that you can increase the D gain. So let's just increase that D gain a little bit. Let's take that up to a 0.1 and see what happens. See if that makes any adjustment. And what you'd find is it doesn't dampen out. Now it's only 0.1. We can go ahead and increase that some. So you can see it definitely is not damping out at that. So let's take this up to a 0.5 as well. Let's see what happens as a 0.5. And then we'll make a stepped input here. And what you're going to find is no matter how much I increase this damping term, this I term oscillation from the imbalance term going up and affecting it, the more damping term I add, it's just going to elongate these oscillations. It's not going to actually dampen those out. And I can go ahead and I can keep moving this up. I can even move this up to a 1 and then do my stepped input. And you can see even, this the I gain is a 2, the D gain is a 1, how these oscillations when I move from there just aren't getting any better. So I watched this in post and I wanted to take this a little bit further than a 1 to make the point on the D gain not being adequate. So you can see now I have the I gain again at 2, D gain I moved from a 1 up to a 2. We're going to go ahead and do a stepped input here. And you can see, again, it does not get any better. That oscillation just elongates like I talked about. So let's cut to the chase here a little bit more. Let's take this actually all the way up to a 3 and just 3.01, that's fine. And then let's do the same thing. And you can see with that stepped input, how that oscillation really starts to elongate, but that D is not taking care of it. Well, let's even go up even further. And you can keep moving that D gain up, and you can actually see here, we will get to a spot where you can see this green output line. I'm starting to get to the D term oscillation point. So I am basically at max D. I'm actually too far. I need to bring this down. Bring this down here. It's max D on this controller is about 3.1. If I go to 3.2, it starts to oscillate again. You can kind of see that and it'll start to build. Well, let's just start at 3.2. Just again, do a stepped input here and let this do its thing. And again, you can see that oscillation really starts to elongate through here. The amplitude gets a little bit less, but again, we're still having an oscillate, and I can't go any higher on D. So at the end of the day, I am at my max D gain. I can't go any higher on D gain. And with this I gain in play and no P gain, there's no P gain in play, I am still having this oscillation with a stepped input that's really elongated out and it will not go away. But let's see what happens when we increase the P gain. So we have an I gain of 2. Let's take the P gain to a 0.1 and see what that does. So let's go ahead and do a nice sharp input. We still have a lot of oscillation there, so that's not enough. Let's take it up to a 0.5, do a stepped input here. You can see that, well, the oscillation is less amplitude. You can see that red line did not go up as high as before. Let's do another stepped input just so you can see that. See how this red line, it's not shooting way up off the graph this time. It's staying within the graphed area. So let's go ahead and increase this P gain a little bit more. Let's set that to a 1. So now we got a pushing gain of 1, a imbalance gain of 2. Let's do a stepped input. And you can see how this amplitude is getting even less. And look how quickly it's now able to settle, the red line settle on the blue line. So again, let's increase this some more. Let's take this up to a 2. Now again, remember what it looked like when I took the D gain up to a 2. It did not settle out that oscillation. Whereas look at this, how as I increase the P gain, that oscillation settles out. Big stepped input here. That overshoots hardly, not that much comparatively to what we were getting before. And look how quickly it settles out, and then the red line goes on to the blue line right here. So pretty quick. Obviously, if I keep increasing my P gain here, just let's take this up to a 0.3 now. Let's take that up to a 3 now, do a big stepped input. And you can see how I'm still going to get some overshoot here. That's not going to completely go away, but it goes up and then settles right back down, and the red line settles on the blue line really quick. So what's the big takeaway? There is a I to P relationship. The P gain damps out the I gain, the imbalance gain. So if you have a slow overshoot or a slow oscillation, and that can basically anything that you can readily see in an altitude hold or a position hold or a rotational rate like a bounce back you would see when you take the quad and do a fast rotation spin, and then you snap the stick to center and it goes whoop and bounces. You can kind of see it in the camera. It goes bounce down and bounce back up. That almost always is the I gain. And the fix to damping that out is nothing to do with the D gain. It has to do with the P gain. And the P gain, you need to adjust that I to P balance. You need to bring the I gain down and the P gain up to adjust for that balance. Now, if you want further and you want to see this really in flight, I have a whole video where I took and talked about the I to P relationship. And that's where I started to call it the IPD controller, because it goes in that order for oscillation damping. You have the I term, the P term damps the oscillation for the I term, and then the D term damps the oscillation for the P gain. Now to check out the last piece of this puzzle, let's set all the gains to 2. So we have a P gain, or pushing gain of 2, an imbalance gain of 2, and a damping gain of 2 as well. Let's go ahead and do a nice step response on that one, nice sharp one. And you can see we had a little bit of P term oscillation there, but even with that, let me just stop this here right there. You can see that after we move the set point here, that the quad starts to move down. Now this gap here, this area, all this area right here, causes this thing called I term windup. So the I term starts to accumulate. This area that it's accumulating over here is it unwinding from the I term windup it built here. So if we can start to see that. So you can even see with these higher gains that I term windup is still there, and then it, you know, slowly unwinds one direction, then the other direction, so on and so forth, and then settles on the set point here. So what can we do to make that better? Well, of course, what we can do is, we've talked about, the I to P balance. So we're going to go ahead and crank up our P gain as much as possible here, and then go ahead and do a step response. Now we can see in this step response that true to what we've been talking about so far, and I'll stop that right here, that we have this I term windup that occurs here. But since now our P to I ratio is higher, our P gain is 5 and our I gain we just kept at 2, there's less than an unwind period here. But you do get into a scenario that as much as I keep increasing my P gain, I will always have some sort of overshoot here due to that I term windup. And that is occurring because of this gap, that as soon as I instantaneously move the set point, my quad or whatever it is always going to have a lag. So there's always going to be a period here where the I term will wind up and then cause the craft to overshoot its target by a little bit. Obviously, the higher your P gain to I gain ratio, the less this will be. Of course, the other thing I can do is always decrease the I gain here some as well. But you can see if I take this down to say a 0.5, then I don't do my overshoot, but I really don't get to that target quite as well. So again, I can kind of make some fine-tune adjustments here. So you can see even at a 1.5, that's still too high. Now setting that to a 1, you can see that it's basically, I still have a slight overshoot here, but that is essentially my optimized I to P ratio. But what that essentially does is it limits how much I can actually have of an I gain here. So once you do find that optimal balance, the optimal balance between the P gain and the I gain, to have it, you know, stay on target but not overshoot, not have too much wind up, you can take both of these gains, and in this case I can't move it any higher, but that ratio between the two, so 5 divided by 1.2, I can hold that and move everything up, move both of these sliders up at the same time. And that won't change this behavior, that intrinsic behavior. But you do get to a spot that obviously if I keep moving up this proportional gain and the I gain together, that I will eventually get to a spot where I hit my D max. And I really just can't move those gains up anymore. So the big negative downside of I gain, that is a restrictive part, is you're always going to have some I term wind up. So you do get to a spot where do you get restricted where you can't move your I gain any higher because it starts to draw too much I term wind up and overshooting it, but your I gain still needs to be higher because when you're going into say a move where there's centrifugal force involved, that it starts to increase the imbalance, the load on the imbalance, and you need a higher I gain to fight back against that. Well, wouldn't there be a great thing if there was a way to say, hey, controller, whenever I make sharp inputs, lock the I term for a set period after the sharp move was implemented? And there's a thing in control logic called I term clamping. And how that is implemented in Betaflight and iNav is called I term relax. But that's for another video. We'll get to that in the future. This video is long enough. And that I term relax in Betaflight and iNav doesn't implement itself all the time. That's only when you make sharp inputs. So if the quad is getting, you know, pushed off course because of wind or other outside influences, or you're dealing with PID tuning for something that's not the stability control of the craft, you know, you're dealing with PID tuning for navigation modes where you don't have I term relax, everything we talked about here applies, and all the things you need to consider for I term tuning, the positives and the negatives of it, and how the relationship between the P and the I gain work is critical to know. So we'll end with that, and we'll come back in a future video where we'll talk about I term clamping, how that works, and we'll show how that really unleashes the ability to adjust a much wider range of the I to P balance and really have a nice ample amount of I gain to make sure your quad stays on the sticks or whatever the target is, but don't have to deal with the negative side of too much I gain that you have to deal with I term windup. So until that one, thanks everybody. Don't hesitate to drop any questions you may have down below, and I'll see you on the next one.